And most of this will be me talking out of my ass, but at this point we're used to that anyway. So today I'm going to be talking about the art of being effective, which is something that I try to strive to be every day. And what that boils down to is getting more return for the work that you put in. And so to tell you what being effective is, first I'm going to tell you what it's not. And that requires talking about the three E's: effort, efficiency, and effectiveness. And the way I look at it, every time you approach a project, if you do it successfully, it is going to have one of these three things in it. Now, I'll talk more a little bit later about how to combine them, because honestly the best results require putting in all three of these. But the most bang for your buck comes out of effectiveness. But first we'll talk about effort. So this is you, and somewhere off the screen is your boss or whoever is going to assign you something. And when they first put you on a project, they're going to explain to you what their expectation is. So they're going to map some arbitrary point out there and describe to you with words what they think they want. Now, unfortunately, what most managers don't realize is that there's something called the cone of vagueness. Now, that's a patented term, thank you. I opted for patent or trademark for other reasons. But when they describe their expectation, they don't realize that what they're actually describing is a huge amount of space in this arbitrary two-dimensional plane. There's a world of things that they could want. They think they're being specific. They think they describe to exactly what they want. But in reality, communication is not perfect. And what you're probably going to deliver is not really what they want. Now, when you put a lot of effort in, or effort-based people, hard workers, generally wind up just mapping some point that they know is somewhere in that cone. They think it's the expected. In reality, it's not. And they just put in a huge sprint, 100 hours, and then they go back to their boss and say, this is what you wanted, right? Now, unfortunately, the boss tells them, no, that's not what I wanted. You're actually about 50 hours away from there. So the hard worker, being a good employee, puts another 50 hours in and eventually does arrive at the real expectation. Now, this is great because it gets the job done, but unfortunately it took 150 hours and now your boss thinks you're an idiot. So perhaps being a hard worker is not the best approach, which is why other people look for being efficient. So again, when you're efficient, you have the same basic setup. There's you, your boss gives you some expectation, they still fail to describe it perfectly well, but instead of putting in 100 hours right at the start, you put in like 25 hours. And then you ask your boss, is this going along the right path? And they'll tell you yes, but it could be more direct. So you put in another 25 hours, and then you give him the second deliverable, and he says, okay, that's a little bit closer, but keep pivoting it. And so you keep doing this until eventually you arrive at the expectation. So you still got it right, and this time it only took you 100 hours, and your boss is much happier with your work because now you're asking questions. Now, at this point, I'm going to point out that the interesting thing is the first thing I showed you is waterfall, more or less. So waterfall is we put in a whole lot of research, we try to understand what the expectation is, we put in a huge sprint, and unfortunately by the time it's over, the expectation had probably actually moved to a different location. And what I just described here was agile. So you keep showing them iterations and you keep changing based on those iterations. So waterfall requires hard work, agile requires that you be efficient. But then there's being effective. So effectiveness is, again, same basic setup. And when you have that cone of vagueness, what you actually do is you just walk in place thinking about it for 25 hours, trying to understand what the problem is, what other ways exist to solve it, and then convince your boss that his expectation is actually right next to you, and then just spend 5 hours. Now, being effective is great because one, you get to be lazy, and everybody knows that. But two, it only took you 35 hours, and now your boss thinks that you're a genius because you just saved the company a whole lot of money so that you get a raise. So not only did you put in less time, you got better results. So I'll go into a couple of examples. This first one, I'm just going to describe it, and you guys are going to tell me which one of the things that I applied there. So when I was at SpaceX, we all know I had a miserable time there, but at least I learned a lot. At one point, I was working on a $3 million contract with NASA to let us use their wind tunnels to test what's called the grasshopper. So that's what you see here. That's the nifty thing Elon came up with to land the first stage of a rocket on those legs. Now, nothing like this had ever been done before in history. Nobody ever tried to land the first stage because there was no reason to. So in order to test how feasible this was, we had to do a wind tunnel test. So we have to test exactly what this would be like, but in a situation where a failure doesn't mean losing $300 million. So I got off the phone with NASA when they told us you have 5 days to make an entire entire 1:16 scale replica of this entire rocket with 144 transducers all the way throughout it, so you need a custom PCB for that, which, by the way, has to be somewhere in the area of around 10 feet long, so not anything trivial. And you have, 5 days until you can use our wind tunnel. You can either do it then, or you can do it 2 years from now, the next time it opens up, and go ahead and build all that. So now I'm in charge of this project, and I have no idea what to do, because I'm an intern given way too much responsibility. So I did the only thing that I realized that I possibly could, and just started working as hard as I could, as fast as I could. And I put in 36 consecutive hours building a PCB, went home for 6 hours to sleep, and then came back for another 36 hours of straight PCB development. And fortunately, we got it in on time. We managed to print these things, somehow test them, they work, and we got the wind tunnel test going. Now, this was great, it made a lot of people happy, but why did it suck for me? Which one of the 3 E's was I in this scenario? Yep, it was effort, and it sucked. I don't want to put in 72 hours over the course of, over the course of 80 hours ever again in my life. I thought I was going to die. So the next thing I'm going to talk about is a hackathon project that some of you may or may not know about. It's called Quickly. We made a sensor at Penn Apps that got us 3rd place in the grand finals that we marketed as being a wearable that detects your bad habits. So whenever you take an elevator, it'll post to Facebook that your friends should shame you. Whenever you smoke a cigarette, the same thing happens. We know when you go to McDonald's. All these wonderful things that have changed my life. Now, what I really want to comment though is hackathons in general. So the thing that's really great about hackathons, the reason you get so much work done in a short amount of time, is because you're removing a lot of operational inefficiencies. So when Kiana, Sebi, and Aaron are all in one room, for example, working on a hackathon project, there is no loss of communication. Every time Sebi fucks up, Aaron can slap him in the back of the head, and I'm sure that happens a lot. And there's a lot to be said about that, because normally that takes forever. Like, it takes a long, long time for people to realize that you're messing up, but when you're all sitting right next to each other, you don't have that problem. On top of that, there is no context loss. That's probably the biggest place where you gain a lot of time back. Because imagine you're working a 40-hour week, at some standard job. Say you work at Microsoft. Then every day you put in 8 hours. And that model doesn't really make sense for a lot of us, particularly the kind of people here. Because if we start working on something for 8 hours, we don't want to put it down after that. 8 hours is at least what it takes me to get in the zone. After that, that's where I'm working the most. And so every time I have to put that down and pick it back up, I also have to remember, okay, where the hell did I leave off? For me, I'd probably spend the first hour just trying to figure out what the fuck I wrote the night before. And that sucks for me. But hackathons are which of the 3 E's, because we remove a lot of those issues. Yep. There you go. And you can all guess what the next one is going to be. So one of my favorite things that I worked on at Microsoft was last summer, when I was told on my first day, this was my second time being at Microsoft, that I would this time be working with Excel's online team. So the online version of Excel that most of you probably don't even know exists. It is a competitor to Google Sheets, but nobody uses it. And they told me on my first day that I would be building a mobile application that allows on-call engineers to know when there is an issue in real time. So for those of you that don't know, an on-call engineer is the person whose neck gets strangled when Excel goes down at 3 a.m. and nobody's in the office. So there needs to be somebody whose head is on the line who has to immediately drive into the office, figure out what's wrong, and fix this problem for the million people that are experiencing it. So my solution to this problem was to spend 3 days actually talking to all of the on-call engineers, there were 6 of them, and trying to understand, despite what my manager told me to build, what would you actually like. And I understood that the big problem is that there are no effective tools around using the particular data that alerts people when there is a warning. And Microsoft also has a lot of really, really smart machine learning experts. So my solution, instead of building this mobile app that would not have solved any problems, was to propose to my manager that we instead allocate a series of data scientists who are building an automated tool that detects when errors occur and automatically fixes them, because we have more than enough data to do that. And my proposed solution for getting data scientists interested in that project, and quick solutions right away, was to hold an internal Kaggle competition for people to do a machine learning style hackathon to understand the patterns that exist in it. Now, this made them really, really like me because, unlike most interns who were afraid to do anything other than exactly what they're told, my response was, I will not do what you want me to do because it will waste company resources. Here's what you should actually do. And most companies will actually really, really appreciate that approach. Like, if you have the balls to do that, the company will seriously promote you pretty quickly. So now that I've gone through a few examples, I'm going to go through just some quick tips of how you can be more effective. And the first one is to just be lazier. I remember reading some World War II general talking about how his best troops are the people who are both smart and lazy. And it's because lazy people come up with cool solutions to problems. So I'm going to open it up because Jordan is the one that introduced that as a way to extend the amount of time that the presentation takes. So who wants to give an example of when them being lazy led to them giving an effective solution to a problem?
We're all lazy pieces of shit, come on.
Are you raising your hand?
No, I was calling for someone to say this.
Jordan?
So we re-roofed our house, and I am very lazy and don't enjoy carrying things with 100-pound shingles up on my back when I'm 9 years old. So we decided to, instead of trying to figure out a way to like pulleys and stuff, maybe lift up a bunch of shingles or scramble on our own. We sat around for a while and then realized that a ladder is a lot like a track. So my dad gave me, I think, $20 an hour, which is a heck of a lot of money for a 9-year-old, to build a shuttle that would take and use a winch that we had lying around, and the ladder is a track to carry up a couple 100 pounds of shingles at once, so that we didn't know where it was kind of stuck with our battery, and all of a sudden we were able to not actually have to carry anything, so it was great.
That's a very good example. And it reminds me of another one from history that I was going to give on this slide. Does anybody know why the trebuchet was invented? So I assume you all know what a trebuchet is. So I believe it was Alexander the Great's troops that first thought up and implemented the trebuchet. And it was because previously catapults, the way that they're loaded, required you to put a big rock on there after you first have like 3 dozen men spend an hour pulling back on this thing and finally restraining it into place and then putting a loader on it and you can launch it. That's great, but unfortunately it also takes 3 hours every time that you want to load it up. And that's not very good when you're trying to siege a wall. So some engineer, who was also somebody that had to load this every day, was tired of doing that, and they did not want to spend 3 hours loading this constantly on the battlefield. So they thought of using counterweights on these trebuchets. So now building one, they never again have to spend 3 hours. Now it takes 20 minutes to load this, or less time. Now obviously the technology has improved. So their laziness led to them coming up with a really great solution that really changed history, especially since it was later adopted by the Mongols and allowed them to tear down the part of the Great Wall of China. So it's pretty cool. Next tip, look for the shit nobody else is taking advantage of. This is actually a really big one because it leads to both sides of the effective equation. What I said about being effective is you either put in less time, less effort, less resources, or you get a higher return, or preferably you get both. So either increase the numerator or decrease the denominator, and this is something that can really do both. And a good example of this I'll show you later when I go through the effective approach to being a student at RPI, which is a really fun one that incorporates all of these things. But I think another good example is the guild itself. So the guild started when I was thinking to myself that there's a bunch of these awards that I would really like to win because they'll help me find jobs and they come with money which will help pay for bills. And I started doing some research into it and found that there is a shitload of student competitions that nobody knows about. Nobody's taking advantage of them, including a bunch of them at RPI. Every year RPI gives away $65,000 in award money with no strings attached and nobody takes advantage of it. So we started taking advantage of it with the Change the World Challenge, which in and of itself was a very effective competition because you write one paper and you win $1,000 for it, and then there's 10 winners a semester, so it was a pretty sweet deal. So our effective solution to wanting to win awards and get money, get recognition, was to just start compiling all of these competitions where we had very, very little competition, where we could submit and be one of 10 entries. Does anybody want to give another example of looking for the shit that nobody else is taking advantage of?
I like the example of a bunch of people, I think it was a project we made, trying to do OCR on books and stuff, and like old manuscripts. And they realized that at the same time that a bunch of people online have to prove that they're people, you can go ahead and just take the pictures you don't know how to read from Project Gutenberg stuff and use it in conjunction with the captchas that you're already doing, and all of a sudden get three people to reverse your like mechanical turk, no traffic.
Yeah, I really like that example. Google adopted it as well for tagging houses and Google Maps. Duolingo does a similar thing to teach people other languages. I don't know how good of an example it is of looking for the shit nobody else is taking advantage of. I guess it is taking advantage of captchas, but it's definitely an extremely good example of being effective. Carl?
Well, I think something closer to home is more that people at RPI, for whatever reason, don't jump on the chance to get in undergraduate research projects, even though the professors are like, we want to give you money, we want to give you things, come work with us, please, and no one's doing it. So it's really easy to get into research.
Yes, it is. Did you have something else to say, Dan?
You want to tell the story of how we got to CES?
Oh, yeah. So CES, the Consumer Electronics Show, I assume we're all familiar with it. It's where every year the big gadgets get announced in Las Vegas. So, what was it, 2.5 years ago? Something like that.
No,
Dan
it's
and
not
I,
a year and a half because it was before we were after.
So Dan and I learned through our friend Ant-Man that Jackson, this is how we met Jackson actually, was doing an undergraduate research project with Google Glass. And we just really wanted to play with Google Glass because we thought it was cool and it just came out. So we contacted Jackson, and being very qualified people, he immediately called us, emailed us, texted us, edited us on Facebook and LinkedIn, making it in all ways obvious that he was desperate. Now, we joined this project and wound up doing probably, how many hours of work would you say you put into your spectrum detection algorithm?
Maybe 30.
Yeah.
Over the semester.
And I would say over the course of the whole semester, I probably put in probably 25 to 30, around the same amount of time. And out of that project, we both got to wear Google Glass for an entire semester, which was cool. We both got A's for 4 credit courses, which was great. I got a company out of it, which I'm about to sell for probably a nice, effective bundle of cash. And more importantly, we all got trips to CES. So the university really wanted to take advantage of the fact that they have a bunch of students working with sexy technology. So at no cost to any of us on the team, we all got free trips to Las Vegas, where we got to meet some of the sexiest startups and play with some of the sexiest in tech. So for us, that turned out to be a really effective use of our time. And I'll actually be talking a lot more about undergraduate research projects again later when I go through the example of RPI. So next thing, try to get more return for the same amount of work. And that plays into what I was saying before, increase the numerator. How can you recycle the work that you have already done? And my favorite example of this, albeit one that backfired, was a friend of mine from high school, who Kiana probably remembers, Samaikia. So Samaikia was a very interesting person, very weird, grew up on a farm in India, and I like to think that he did not see civilization for the first time until the first day we met him. Now, he was taking 2 courses at the community college at the same time, Intro to Computer Science and Intro to Psychology, 2 very different courses, both of which end with write an essay on a topic relevant to this course. So he wrote 1 essay and he turned it into both courses, hoping that that would be an effective use of his time, that he could just spend 5 hours writing 1 shitty essay and 2 passing grades. Unfortunately, it did not turn out that well for him, because he wrote a paper on, it was supposed to be about artificial intelligence, but it wound up just being more about programming. So in the computer science course, he wound up getting like an 80, and in the intro to psychology course, he got a 0.25 out of 100. It was probably the best time I've ever had reading a paper, because it would have more red ink on it than printed by the time the professor was done with it. So Samaikia had really effective intentions in his heart at the time, but it just did not pan out for him. I An example where it does work is what we do again in the Guild, not only funding those competitions, but coming up with a couple ideas that we submit to every single one of them. So Resumazing turned out to be a really good example of that, even though we're actually pursuing it as a company now. But originally it started as, hey, we can win a bunch of competitions with this. So we came up with one idea that we submitted to the 3 competitions. From the ones that won, we brag about it more. From the ones that we lost, we asked them, why did this lose? Then we incorporated the feedback into it, and we submitted it to 5 more competitions. And over time, we just got to the point where we're not doing anything. We're just getting, I just wake up to emails that I just won $10,000. And that's a pretty sweet place to be in. Unfortunately, it also leads to stress because I just learned that I will be missing graduation because we won a competition that requires me to fly out to LA and pitch a bunch of VCs at that time, which is cool, but at the same time sucks. But it was an effective return on the little amount of hours that went into that application. I think it actually took me less than 3 minutes to submit that application. So, and it was greatly thanks to Jordan too. Jordan submitted in that your video that you made for.
You just rehashed it?
I didn't even rehash it, I just submitted the exact same video. So for our Chinese business model competition, Jordan presented, because he wanted to get more project experience, or more pitching experience, and while we took second place in that, it was a nice $5,000, we also recorded the pitch. We submitted it to the International Business Model Competition, which got us in there, which we won 3rd place for another $10,000. And then we submitted the same video to Recess, the video we just won, so now we also get a free trip to LA to pitch a bunch of VCs, courtesy of Mark Cuban. So next one, determine the actual point of what you're doing. And this one's really hard because a lot of times, especially being our age, we're just told what to do. Like for a class assignment, for example, you're just given this arbitrary thing, and you never stop to think, well, why am I actually doing this? Like, what is the value that I hope to get out of it? Because you want to be able to circumvent that. So, one of the hardest things that I've gotten from any of my mentors is that sometimes you have to ignore school assignments because you have more important things to do, and that's completely against everything else that we're doing. So, right now I'm taking operating systems, and that class, the whole grade is comprised of 10% for each of the 4 homework assignments and 30% for each of the 2 exams. Now, my way of looking at it is, I'm a senior, I am going to RPI. At this point, I'm only still here to get a degree. The piece of paper is, for whatever reason, for the reasons important to me, the only thing that I want out of taking this class. And the only thing that I need to do to get that is a 60 or higher. I just need to pass. Which means I can now look at that rubric and I can decide which of those point values I can just ignore. So I completely ignored the second homework. I lost 10 points off my grade, which I don't give a shit about. And instead I got to go to California to show off writer's block at the game developers conference. So it's all about trade-offs. Like, what are you actually doing this for? I am not actually doing it to get a good grade, so why should I bother getting a good grade? Who wants to give an example of when they drop something because they realize what they're actually working on? Yeah.
Good example, changing majors 2 times to realize that I don't want electrical engineering and I'm computer science, but that was all I was doing anyway.
Yep. So Dan and I have changed majors many times, and we have done that many times together because we would just get out of like signals and systems, for example, and realize, wow, this class sucks and I hate it. Why am I actually doing it? And we realized that we're doing it because it is a requirement for electrical engineering. Now, why are we majoring in electrical engineering? And we could not answer that question. So we switched to computer science. And I will go through again in my example later why it's fun to be a computer science major and why it is the easiest one by far to take advantage of. Surround yourself with smart people with different strengths. Because that's exactly what we're doing here. We all have expertise in different areas. You gain a shitload out of having a support network. Mainly because, the next point, you can barter your skills. So a great example of this is exactly what Dan and I are doing right now. Dan is working on the operating systems homework, which I will also get credit for, but in turn, when I did the work on this, I did a lot of work, and so did Kiana in software design and documentation. So while we were individually taking these classes, you have to look at it as a group thing. if you can avoid doing your work in one area where you're not so strong, and instead barter the skills that you are very strong in, then you can make much more effective use of your time. So Dan is much better at writing C code than I am, but I'm also better at pitching games that I design. So it makes more sense for me to put in an hour to finish what would have taken him 5, and for him to put in an hour for what would have taken me 20. It's just a better use of time overall. And I'm sure you guys do that every once in a while when you're working on, but do it like all the time. Anytime you can do it, you want to. Does anybody want to give an example?
So my roommate tends to be like, he just like doesn't care about his computer, and I'm an artist when I make like enthusiast computers, right? So I build this computer every time he does something different with it. I'm the one who puts it together. He gets a new case, I rewire the whole thing for him, no questions asked. And I ended up getting an iPad out of it when my year anniversary came around. He ended up just like throwing me an iPad. Like, hey, thanks for all that you've done. So kind of in a way bartering because he had access to money at the time. So.
Yeah, I mean, that is a really good example. And part of the last 2 points, but a good point in and of itself, is to make people trust you, because that is the number one way that you're going to surround yourself with smart people so that you can start to barter your skills more effectively. There's a lot of things that go into making people trust you. I could have done an entire talk on just this, but instead I only got 4 words on the slide. And really my strategy to it is to be humble and be cocky. A big part of being effective and the way that I choose to live my life is the philosophy that everybody is comparing their entire film against just your director's cut. They're comparing against just your highlight reel. Because think about it, do you tell everybody about everything in your life, or do you just tell them about the things that are noteworthy? It's probably some combination thereof, but one definitely gets more focus than the others. And you need to play that to your advantage. You should definitely be boastful about the things that deserve bragging. Because people need to know that you're qualified. They need to know that you're somebody that they can actually rely on if they're going to work with you. But at the same time, you don't want to be an asshole. Like, you don't want to be somebody that they can't imagine working with. You want to be somebody that they'll go to when they need help, but who also appreciates the value that they bring. Which, for me, one of the things that Matt said yesterday in his Fireside chat was not to have an ego. And that in what we have, we don't have an ego. But I don't think that's true, and nor do I think that's the best solution. I think that you should have a group ego. So to me, I don't brag about me, I brag about the guild. I see all of your achievements as being an extension of my own achievements, and I will brag about Diogo's achievements as much as I brag about my own, as much as I'll brag about Dan's or Jordan's. And that makes people trust you. And all they hear you say is we, and when they hear you praising the things that they did in order to make the entire group seem more impressive, it goes a long way towards making people trust you. And you'll just see that that's tremendously helpful everywhere in your life. And again, you're welcome to ask me more about this particular topic. I recommend reading How to Win Friends and Influence People by Dale Carnegie. I know you've probably read it, right? And Jordan probably has as well. What's his famous quote from that?
There are a lot, but I mean, one of them was like the Swedish phrase, I would never think of as their name or something like that.
Well, that's a good point too. I was thinking of the be something, be boastful in your praise, or hearty in your approbation.
Lavish in your, hearty in your approbation, lavish in your praise.
Yeah. Yeah, it's a good book. We should all read it. So now we're going to talk about the application of all these things. So we're going to go through kind of like a case study of how you can apply this specifically toward being a student at RPI. So like I said, Dan and I changed majors many times. I personally have changed majors 8 times for a lot of different reasons. But the last time that I changed it was because I realized that electrical engineering has many requirements, and computer science is a pathetically simple list of requirements that is very easy to take advantage of. Now, unfortunately, only Carl here is a freshman, I think. But if you can manage to get to any of your siblings or anyone else you know before they come to college, you should recommend that they take advantage of some of these things because they will get much better bang for their buck. So let's look at this a little bit. If we look at it, we see one section is the CS actual required core. So this is what, 7 classes? I'm not counting computer science 1 because that's a general requirement for a lot of different majors. But a whole major is 7 required courses. That's it. It's 128 credits total. Only 7 of them are actual named requirements that are within computer science specifically. The next part is CS electives. So there's 3 of those. There's not a lot. We'll talk about them more in a little bit. Then there's the core requirements. These are the things that no matter what major you are, you have to take these things. Generally, people will get out of them with transfer credit or APs or other things. Then you have your math and science electives. You have your HAS electives, which take up a ridiculous amount of space. What is this, 6 courses, 24 credits just on HAS electives? And then the free electives. That doesn't make any sense. 32 credits dedicated to free electives? That's an entire year. What are they thinking? Like, how do they trust us with that? It just is insane to me. So let's start taking advantage of it. Let's look at things that RPI offers that they might tell you about in passing, but they really should have an entire friggin' course on them so that you have to take advantage of them as your student at RPI. The first one is undergraduate research. So I talked a little bit about this, Dan spoke about it, Carl spoke about it. The thing that's awesome about undergraduate research is, one, you get real life work experience. Well, kind of real life work experience. It's definitely more applicable to people that want to go into academia and industry, but even people in industry see the value in it. Now, the other thing that's really sweet about it is that it is a guaranteed A. Like, no professor is enough of an asshole to not give you an A for undergraduate research. Another huge benefit to it, if you know professors in particular areas, you can basically get undergraduate research with any course code. They count as 4,000 level classes. Now, read the rule book when you're trying to take advantage of things. You can apply these towards any of the HAS or free electives or the science and math electives, but you cannot apply them to your computer science electives. So when I go through looking at the math again, I'll talk to you about how to get around those. But undergraduate research can be used towards anything that says free or HAS elective, which is ridiculous. They're all free A's if you take advantage of it. The next part is independent studies. So these are very similar to undergraduate research. Structure-wise, they are exactly the same thing. The only difference is that the university matches pay on undergraduate research. They do not match pay on independent study. So for you, that means nothing. Now, the thing that's awesome about independent studies is you get every single one of the advantages of an undergraduate research project, but you get to decide what it's on, if you know the professor. You get to decide the scope of it, how many credits it's worth, what area it's in, and what I found really cool is that you get to decide the title of it. So I have the Inventors Guild on my transcript, I have Hacking the Power Glove on my transcript, EEG control systems, closed loop biometrics, and a few other ones. My favorite one is one that somebody made with Professor Chang called Fuck the RIAA. Now, Chang has gotten to the point where he's really cool to do independent studies with, by the way. Like, he's pretty relaxed and like he'll let you do a lot of really cool things.